By this film, we will start using function blocks in PLC programming. I will start with the SR and RS function blocks, latches, which we can use in, for example, FBD programming. We have studied latches in both ladder and in relay logic in previous films, and we used the latches in this example where we had a motor that should remain started even if we released the start button, and we saw that we had different configurations for a start dominant latch and a stop dominant latch. In the ladder example, we made connections to the PLC hardware, and any programming language that we use in the PLC will use this configuration. Remember, the stop button should be normally closed. The RS function block looks like this if it's inserted into a ladder program or a function block diagram program. We have two inputs, one set and one reset 1, and we have one output Q1. This function block is a latch in itself. It's an RS latch, which means that if the input set is true, the output will be true, and it will remain true when the set signal becomes false. The output will be reset, it will become false when the reset signal is true. This latch is reset dominant because if both set and reset are true at the same time, the output will be false. We can see this in the table here, where we have all possible values of set and reset. If both set and reset are false, the latch remembers the value of the output it had from before. That's a latch function. If set is false and reset is true, the output is false. And the other way around, if set is true and reset is false, the output is true. And here we can see that it's reset dominant. If both set and reset are true, resembling pressing both the start button and the stop button at the same time, the output will become false. We can see one other thing about this function block, and actually all function blocks. They need to have a name, an instance, because this block, it requires memory space as it is entering the memory phase here, and therefore we need a name to allocate that memory space. Just as in the ladder latch or in the relay latch, we want to have a start dominant form as well. And the function block for that is called SR. The SR function block is set dominant. We can see that on the S coming first, and also that we have the number 1 after set, in contrast to the RS latch, which was reset dominant. We have the R first, and we have the number 1 on reset here. The SR latch is a latch, which means that we have this memory phase when both inputs are false. It remembers the last thing that happened. If the output was true, then it will remain true when both set 1 and reset are false. The output is false if the reset input is true while the set input is false, and the output will be true if the set input is true and the reset input is false. The difference from the RS latch is here. This is set dominant. If both sets 1 and reset are true, then the output will also become true. So this is set dominant. When we are pressing start and stop at the same time, the system will be started. And as for the RS latch, this function block also needs a name, an instance. I will use those function blocks in an example in codices in the next film, but for that film we will need some more blocks. We will need to have some pure logic. Those blocks are called OR and NOT. We also have XOR. NOT can also be achieved as a circle on the input or the output of a block. We can make that by right-clicking on the line here just outside of the block, and then we can choose negation. And then, of course, we have the set reset latches, RSSR. We also have timers. I will show them in the next film. We can make basic calculations, add, plus, sum, minus, mod, multiplication, div, division, and mod for modulus. And we can compare two numbers to each other. We can see if they are equal, greater than or equal to, less than or equal to, less than, and not equal to. In the next film, I will show an example of the set reset latches, and in the film after that, I will use the timers.